Okay, in this video we're going to talk about distance and displacement, but before we talk about those two things, we need to talk about scalars and vectors and what they are in the world of physics. So scalars are just any sort of quantity, any sort of measured quantity that has size in units only. Vectors, on the other hand, have size, units, and they also have direction. And there are many examples of both scalars and vectors in physics, so we'll talk about these right now. So the first one in the scalar section is distance. We also have speed, time, mass, and energy. So they're just to name a few. Vectors, we have displacement, and these, the top two there on either side, are the ones we're going to talk about in this one. Velocity, force, acceleration, and momentum. So these are just to name a few on both scalars and vectors. So scalars have size in units, vectors have size, units, but they also have direction as well. So let's consider a wee guy, and could be you. He's at school, and at lunchtime he wants to go to the shops. Now, generally when you have to walk from school anywhere to anywhere else, you can't really just take a direct route. You have to kind of go around some streets, turn corners and things like that, because you can't run across other people's gardens. So you have to take a slightly longer route than expected. So if we were to just take a random route and then total up all the distances measured along your journey, to get the total distance, all we need to do is add all those single distances together. So the total there, 245 metres. But what if we take the direct route? Now we can't necessarily take that, but a bird, for example, could take that quicker route. Sometimes they call it as the crow flies. And this route is known as the displacement. But how can we actually calculate the displacement? Well, let's take a slightly simpler example. So we'll take the wee guy at his start position, and let's say he goes a certain distance that way, and then turns right and goes this way. So 50 metres upwards, and then 70 metres to the right, and that's where he finishes. Now in this case, if he was to take the direct route, then he would go from start to finish directly at an angle, and that would be the displacement. Now to get the total distance, again all you need to do is add up all the single distances together. So that'll give us 120 metres. Now, how are we going to get the displacement, which is the red dotted line? Well, displacement is a vector quantity, so it's going to have a size, it's going to have units, and it's also going to have a direction. Now you'll see that the distance doesn't have a direction. This is the difference between distance and displacement. The displacement has a direction as well to consider. So let's just cut it down into sections. So let's try and figure out what the size of the displacement is first of all. So if we take our shape again that we made with our journey, so we know that two sides there, 50 and 70, and this is our displacement side. You'll see we make a nice wee right angle triangle. So that means we can use Pythagoras theorem to figure out what the length of that dotted red line is. So we can use a squared equals b squared plus c squared. So let's call the dotted line A, call 70 metres b, and the 50 metres c. So if you put in those numbers into the equation, 70 squared plus 50 squared, so that's b squared plus c squared, multiply them all through, then add them together, and finally take the square root, because remember it's a squared, but we're just looking for a, and if you round it up you should get about 86 metres. So that's how you get the size for the displacement. Next thing we need is the direction. So again, map out our journey. Now you don't necessarily do this twice, you can just do it all in the same diagram. 50 metres and 70 metres again, draw in the displacement. Now we already know that that's 86 metres. Now what we need to do now is put in a little compass point, so we'll just state that upwards is north, to the right is east, down is south, and left is west. Now our general direction of our example journey for displacement is around about northeast if we draw it on our compass point, and the angle we're looking for here is, we're going to call that theta, alright, and that's the angle that you're leaving from, so the angle at the start line there. So to get that angle we're going to use trigonometry, or in other words SOHCAHTOA, if you've learned that in maths. So sine, cosine and tangents. So we're going to label the displacement side hypotenuse, the line across from the angle the opposite side, and then the other side's adjacent. So we'll just use the sine one here. Sine theta equals opposite over hypotenuse. Sine theta, that's going to be 70 over the 86 metres. So then we just plug that in your calculator. Once you've taken the inverse of sine, and you'll get 54.5 degrees. Now we also need to put in the compass direction there. We are generally, if you look at your compass points in the top right hand corner, you'll see that it's northeast. So that is your direction. Now the next stage, what you need to do is combine both the size that you had in the Pythagoras part and the direction you got from the trigonometry part. So the total displacement for that example is just going to be your 86 metres, 54.5 degrees northeast. Now that direction looks a bit clumsy. You could change it into a bearing if you wish. You can leave it like that if you want, but you could put it in a bearing. So how do you do that? Well, what is a bearing? Well, when you talk about a bearing, you're looking at how far away you've been moved from north. So what angle you've been displaced from north. So in our case, it's around about 55 degrees we've been displaced from north. So we can write our final direction, our final displacement is 86 metres, brackets, 0.55 degrees, close brackets. And that's how you can get the displacement in a journey. Now remember, the displacement always needs a direction. Distance does not need a direction, it just needs the size and the units. And the units for both displacement and distance is metres.